All right, so today we are talking about set of mark prompting, which is a really cool paper, which helps with grounding vision models. So in some of the previous papers, we learned that grounding is difficult. And what is grounding? It's a way to, it's a task that a visual model or a multimodal model has to do in order to actually perform a task. So when you're building an agent to perform a task, you give the agent a high-level task. The agent needs to find a series of low-level steps to complete this task. And some of the earlier work we looked at realized that the agents or the large language models are pretty good at planning what to do, but pretty bad at turning that plan into an actual thing that can be executed, like a precise thing, click on those coordinates, for example. So the first part planning is good. The second part, grounding, that's bad. The models are not good at it. So what this paper proposes is a way to improve grounding by annotating the image. So as a really short explanation, as you can see on this figure, they demonstrated if you give, for example, ChatGPT Vision, that's the main model they're using in this work. If you give it an image like this and ask, for example, which chair is closer to the window, the model will not give you the right answer. But if you first annotate this image with this kind of, colored, transparent or semi-transparent masks and some numbers, and then you give that to the model together with the same question, it tends to do much better. So this kind of mask, the colorful masks and the numbers, somehow give the model things to hook onto so that it gets better at understanding the spatial relationships between things. So now if I want to find a seat close to windows, where can I sit? It tells you that you can sit on the chair numbered as 7, whereas before it said something else that was wrong. So that's kind of cool. It's a nice idea. And basically what this paper says is that you can use an off-the-shelf semantic segmentation paper like SAM, so Segment Anything, some of the earlier work from Facebook. And that will be enough post-process or pre-processing for these kinds of images, so then you can annotate them in that way and get better results. And there's a lot of, they've run a bunch of experiments, and they have some explanations for why they think it works. And I think it's a cool idea. There are some details about how to do this, like where to put the labels exactly. Like, for example, centers of objects are somehow problematic because if you have a large object and a small object kind of inside it, the centers will overlap. So they have they've experimented with different ways of aligning the labels in the right ways, and also what kind of labels to use. So in this, first example here, they're just numbers. They've also experimented with different labels that are like 2 characters or a single character. And basically they find that it depends on the task. So if you have an image that already has a lot of numbers, then you probably shouldn't use numbers as labels because that will be confusing to the model. Then you should use letters. But if you have an image that's maybe like a document and has lots of writing on it, then it's better to use numbers so that the labels are not confused with the actual image content. One other thing that I really liked about this is the ablation study that they did. So they basically tried to remove different parts of the pipeline, and that's how they figured out that numbers might be better than letters in some scenarios, and so on. I also like the qualitative observations. That's something that not all papers have, and I really appreciate it. After the authors write a paper, they have to present all their results in sort of a quantitative way, which is great and really useful. But they also get a lot of subjective impressions about the world or the thing they looked at, and they don't always include it. And in this case, they did. So, for example, they found that in some data sets, the golden annotations are not always as good as they were hoping. And that center marks are not always the best, as we discussed, and a few other things that are kind of interesting. Also funny that related work is in the end. That seems to be a trend that I'm not sure how I feel about. But overall, I think the problem still remains. they show a bunch of experiments and definitely makes things better, but even using this technique, you're not going to get perfect results out of GPD for vision for localizing things. Thanks.